This video is having to do with heat equations. The three following heat equations we are going to be using are our water heat equation, which is 500 times GPM times differential temperature of the water. Our air equation is going to be 1.08 times CFM times differential temperature. And our electric equation is going to be kilowatts times 3413 equal BTUH. Heat transfer is a core component of the design of your project. Sensible and latent heat. For the purpose of this exercise, we will be calculating sensible heating, except when measuring the water temps. Latent heat is tied to state change, and the examples that follow have no changes in state. It's pretty relative unless we get into steam or gases. BTUs, for transparency, we will convert all units to BTUs. Test data. Your heat exchange test report data shows the design team empirical performance data. This is a valuable performance and troubleshooting tool. Take heart, these calculations are as simple as fan law equations, and as long as they are planned into your work schedule, they take little additional time. Lesson 1. Electrical heat coils. Kilowatt and BTUs are two ways of looking at the same results. In the following real-life equipment schedule, we will use two separate formulas to show that BTUs and kilowatts are relative when we use the formulas provided. Here you will see we have, wait for it to load, here we go. Design kilowatts to BTUs. Kilowatts, which is 15, times 3413 equal 51,195 BTUs. Total CFM times delta T times 1.08 equals 1320 times 36 times 1.08 equals 51,322. This is a good way to cross-reference your numbers. BTU is often weighted. The tab calculations in the tutorial provide BTU answers in BTUH. By using BTUH, we are able to determine how much heat is flowing in a given amount of time. It may be kind of sloppy, but BTU is often used when people mean BTUH. I've done it both ways here. Lesson 2, hydronic coils. Here we will calculate the BTU transferred from the coil to the airstream. This heating water exchanger report was taken from a recently completed job. We will take wet and dry temperature measurements and calculate changes in enthalpy and BTUs. Once again, please remember we don't have latent heat per se in these calculations. So here we have our calculations. We have our airside differential temperature of 27.8 times our actual CFM of 1615 times 1.08 equaling 48,488 BTUs. On our water calculation, we have a differential temperature of 7.4 times our 13 GPM times our correlation factor of 500 equaling 48,100 BTUH. So this is showing a pretty even exchange of heat. You can check those numbers if you would like. There is a little time before we flip to the next slide. Tip: find the best possible location to test on a unit-by-unit basis. It would be ideal to have uniform locations, but being as accurate as possible supersedes uniformity or easy numbers. Important notes on testing temperatures. Discharge air temp is best taken at the first outlet of the system. Consistency of entering temps is important. If possible, I recommend Note 3. Posture the units as shown in the schedule. This may not be achievable due to seasonality, but the closer the incoming air is to these design numbers, the more accurate those would be. Ideally, I would try this at 100% outside air to give myself the additional locations to take my temperatures. We have to be very cautious of trying not to get the temperatures in a spot that might be too hot or too cool and not indicative of the actual heat transfer. I kind of look at it as getting a accurate traverse. You have to try a lot of locations, and only time will give you the experience to know which locations end up working the best. In closing, I would treat these temps like you would a good traverse, as I just said, and your results will add value to a report. Get your measurements in the best locations possible. Verify the results make sense by cross-checking if possible or using common sense. Review this topic in your Blue Book or trusted resources to deepen your understanding. And I would be leery of using the control contractor's temperature gauges unless you have verified that they are accurate and they are far enough away from other components that you are actually measuring the transferred air.